Welcome. Today we're going to be looking at a few more impacts that we have as humans upon our environment. And mostly what we're going to be looking at today is our effect when it comes to the atmosphere. Today we're going to be looking at air pollution. So first, the idea is you need to understand what the purpose of the ozone layer actually is, and then a little bit about the impacts that we've had on that particular portion of our environment. Next, describe how acid rain is produced. You should be able to understand exactly the process that takes place that makes acid rain. Thirdly, you should understand the greenhouse effect. You should understand how the Earth maintains the temperature that it maintains, and then understand the effects of anthropogenic CO2. So without anything further, let's get this going into the ozone layer. Ozone, specifically O3. That is what ozone is. You'll notice on the side it is 3 oxygen atoms. One of the oxygen atoms is double bonded to the central atom, and the other oxygen atom will be single bonded. That double bond will actually swap back and forth between the 2 different sides, and so it can go either side. That's how molecular ozone is put together. So what it does is it blocks harmful ultraviolet radiation, specific UVB and UVC, from making it all the way down to the surface where we are. So the sun releases this ultraviolet radiation as part of all the different light rays that come out of it, but it gets blocked by the ozone. And that means that those harmful rays of radiation don't make it to us. If ozone didn't block the ultraviolet radiation of UVB and UVC, then the DNA of organisms would be damaged, and that would be detrimental to all life upon this planet. We unfortunately at one point in time released a lot of ozone depleting substances, those are ODSs, into the atmosphere. And when we did, they, of course, did exactly what they sound like they do. They depleted the ozone layer. Typically, these are halogens, something like fluorine or chlorine or bromine. Those atoms are really, really, really bad for the ozone layer, and they would then cause it to deplete. And thus, the sections where it got depleted were not able to fully block the ultraviolet radiation as well as it should, or as well as organisms like ourselves need it to. Thankfully, the ozone layer is always constantly being made, but it's one of the things that we have to be careful of because we need it. We rely upon the ozone layer to block that harmful ultraviolet radiation. That's why we try to limit the amount of ODSs that we release into the atmosphere, because we need the ozone. And that's why we try to limit the amount of ODSs we release into the atmosphere, because we require the ozone layer to be as healthy as it possibly could be. We need ozone in the atmosphere. Next, acid rain. All right, here's how it works out. The key is you get this train that comes in, it was burning coal, it goes to the coal power plant, and it will then be used for generation of electricity, and as that fossil fuel is being burnt, it will actually release, obviously, smoke, and in that smoke will be SO2s and what we call NOxes. That means NO2, NO3, basically one nitrogen atom and some variable number of oxygen atoms. That is why we use the term NOx. When the NOxes are released, unfortunately, they then are going to mix with water and other substances in the air, and they are going to produce H2SO4, which is sulfuric acid, and HNO3, which is nitric acid. And then they are going to get rained upon the earth. And that is how acid rain comes about. So acid rain, as it says, is done when we burn or when we combust fossil fuels. We end up releasing these substances, which when mixed with water and other gases, they produce acids, specifically sulfuric and nitric acid, which cause the pH of the rain to be much lower. That is acid rain. Very simple idea, very simple thing. Moving on to the greenhouse effect. Now, the greenhouse effect is not a bad thing. I don't want you to think it is. The greenhouse effect is what keeps our planet from getting too cold. It's what allows for life to exist on this planet because it keeps us at a relatively stable temperature. We're going to use a very simplistic way of understanding this. The key is we have the sun, and the sun rays are going to be absorbed and then reflected off of the surface of the earth and off the atmosphere of the earth. So the sun rays are going to actually hit molecules in the atmosphere or the actual surface of the earth, and when they get bounced back, they're going to bounce as infrared radiation. And if that infrared radiation doesn't get held within the atmosphere, it would just be released into space, and we would then have a lot of cooling taking place on this planet. It wouldn't actually keep us at a stable temperature. But the key is, there are gases that happen to exist within our atmosphere that absorb those reflected rays. Specifically, water, methane gas, and carbon dioxide. So when the rays are reflected, they get absorbed by these specific molecules and then get emitted back, and thus we are going to be able to maintain a temperature on this planet that is high enough that keeps us able to live. And that is generally good. Again, though, thinking back to the whole idea of eutrophication, remember, there's a balance that must take place. There's a balance in how much of these rays you want to be emitted back, because there's a balance to what the temperature should be on this planet. Not all life can withstand extreme temperature swings, and it's really good that for the most part, our planet has a very stable temperature. Which brings us to the greenhouse gas that gets the most press, and that is indeed carbon dioxide. And the reason that carbon dioxide gets the most press is because it's the one that we have such a huge impact upon. We obviously can't have a huge impact on water. Water is going to evaporate into the atmosphere no matter what we do. We are not going to increase the amount of water that is being evaporated in the oceans. We can't stop water from evaporating from the oceans. It's going to happen. But the amount of CO2, that can be measured from how much we burn fossil fuels and release that carbon dioxide. So when we look at it, the key is we produce CO2, and we produce a lot of CO2, and it's what we call anthropogenic CO2. Anthropogenic means it comes from humans. So when we're talking about anthropogenic CO2, we're not talking about CO2 that is coming from organisms just doing typical cellular respiration. We are talking about the CO2 that comes specifically from humans as we are performing some process. Typically, it is burning fossil fuels. It is a waste product of manufacturing. That's the CO2 we're talking about, and it has profound effects upon our environment. The first of which is climate change. Many of you know that climate change happens, and the reason that climate change is taking place is because as CO2 is a greenhouse gas, if we increase the amount of CO2 in the atmosphere, that means that we are going to cause more of the greenhouse effect and more of a holding on to that heat energy. And as we hold on to more of that heat energy within our atmosphere, that means that this planet is actually going to warm. Now, that warming isn't going to be just straightforward to the fact that means that we're not going to have winters and we're not going to have cold days and we're not going to, it's not about that. It's about an overall average. It's about a global average. It's about the entire biosphere. It's not just talking about your local ecosystem. Your local ecosystem is going to have ups and downs in the temperatures, absolutely. And part of that is based upon how the wind patterns are, which is based upon how the temperature is in different areas. It's all a complicated set of different things, different systems interacting. But as a whole, the temperature of the planet is actually increasing, and that is melting the polar ice caps and causing the destruction of different ecosystems. But besides just causing the climate to warm, it's also having an impact upon the evaporation rates within our biosphere. The other thing that we're causing is a change in plant metabolism. Plants, as they undergo photosynthesis, they are taking CO2 out of the atmosphere. And so as the concentration of CO2 increases, that actually is going to have an impact upon the photosynthetic rates within the plants. And lastly is ocean acidification. Carbon dioxide in the atmosphere is absorbed by the ocean. As carbon dioxide concentrations increase in the atmosphere, it actually gets absorbed by the oceans. And as the oceans absorb that CO2, it ends up releasing hydrogen ions as the CO2 interacts with the water molecules. And that means that you're going to lower the pH of the ocean, which is not a good thing. Organisms that live within the ocean, many of them have a calcium carbonate shell, and that calcium carbonate shell cannot exist in a slightly acidic environment. It will dissolve right away. And that's one thing that causes organisms like crustaceans or other shellfish to just die as the oceans get slightly more acidic. Remember, this is a very, very fragile balance. The environment cannot withstand small change. Small change ends up having a great impact upon the ecosystems. And so that's why slight change in the acidity of the ocean has huge, huge effects upon the organisms that exist in those ecosystems. In summary then, the ozone layer, just so you're aware, it's necessary for life. It protects us from harmful ultraviolet rays from the sun. It's what makes sure that we can actually go out and enjoy a nice day and enjoy being underneath the sun without it damaging us. And combustion of fossil fuels, they have many, many, many impacts upon our environment. Whether it's acid rain or climate change or ocean acidification, it has huge, huge impacts upon our environment. And that means we need to be extremely careful with how we deal with this. We need to be conscious of the impact we have upon our environment and to do what we can to make sure that we have the smallest negative impact that is possible, because we live in our environment. And that means we need it a lot more than it needs us. On that, be awesome, stay awesome.